Hi, we're Group 5, and today we'll be presenting our Machine Learning and AI Python presentation. We are in class IE 4305 at UT Arlington. It's spring 2023, and Dr. Era Bullock is our teacher. Let's get into it.
So just giving you a bit of everything we're going to cover over the course of this presentation. So first I'm going to go into the project introduction. So our introduction is going to cover project and machine learning, then also the machine learning algorithms we're going to be using. So we're going to move on to our first data sets and the benefits of using machine learning algorithms. Next, we're going to introduce our first data set, which is the income data set. Now we're going to consider different types of income, being private, government, state government, and so on. Then we're going to cover the methods we used, which are KNN and logistic regression. Then we're going to go over the income data observations like the marital status, relationship, race, age, work class, and so on. Okay, then we're going to move on to our second data set, which is the wine. So wine is very popular nowadays because, if you're going to restaurants or even just at home, you could just take a bottle of wine. Next, we're going to go over the methods we used. So for the second data set, which is the wine data set, we're going to use a multiple linear regression and also the random forest regressor. Then we're going to go over the observations of the wine, which one of my group members is going to go over in a couple of minutes. Then we're going to analyze our observations, go over the benefits of each type of machine learning we used. Thank you.
In this project, we seek to make use of two large datasets and create an accurate analysis and set of predictions by means of machine learning algorithms. As you all know, machine learning algorithms involve programs that are designed to analyze data and yield valuable information without explicitly being programmed. Also, machine learning algorithms can be a helpful tool to better examine these issues because they can forecast or decide based on specific dataset that is being analyzed. One of the datasets used is income, something that is important to keep track of as it serves as an economic indicator which gives valuable insight to the financial well-being of individuals, households, and countries. Along with that, it gives information regarding other factors involving economic activity such as consumer spending, saving, investment, and wealth distribution. Knowing attributes such as age, education, occupation, and more machine learning techniques can be used to predict an individual incomes, or in this paper's case, whether they reach a certain level of income. Determining this information can help in many ways, such as better workforce planning, improved hiring decisions, enhanced employee satisfaction, improved financial planning, and address income inequality. Also, our income dataset is our binary dataset, where several different factors are taken into consideration to predict whether an individual will make greater or less than $50,000 a year. And these factors include age, work, class, education, marital status, race, gender, country of origin.
Moving on to the methods used for the income dataset, we used KNN and logistic regression. KNN, or K-nearest neighbors, is a versatile algorithm that can be applied to various tasks, and for this project, we utilized it for pattern recognition. By analyzing a large sample, we use KNN to predict whether an individual's income would be greater or less than $50,000 based on various factors. This approach involved recognizing patterns in the data and classifying individuals into two categories: those making less than $50,000 and those making greater than $50,000. So to reiterate, the value will be 1 or true if they are making more than $50,000 and 0 or false if they are not. Therefore, KNN was employed for binary classification in this context. For logistic regression, it was used to estimate the probability of our binary outcome, which is again if an individual is making less than or greater than $50,000. The logistic function is applied to our factors, assigning values to each of them and utilizing their weights and values to determine the outcome. Logistic regression is particularly useful in modeling the relationship between predictor variables or factors and the probability of the outcome, allowing us to identify which factors are most strongly associated with the outcome of interest. Next, we will take a closer look at the dataset and the results using the mentioned methods.
Here is a sample of the income dataset, a very large dataset comprising of around 50,000 observations extracted from the census database dating back to 1994 and is continuously being updated through the UCI Machine Learning Repository. And as you can see, each row represents an individual and the various columns represent the categorical labels of those individuals, including age, education, marital status, relationship, gender, and how many hours they worked in a week. And all these different attributes are then used to predict a binary response variable denoting whether that individual has made less than or more than $50,000 a year in salary. A 0 denotes less than, and a 1 denotes more than. The next slide shows a sample of the histogram charts of those categorical values. As you can see, most of the categorical values don't follow a defined distribution, and those independent variables don't share those same distributions, so it's hard to explain a correlation or dependencies between those variables. So we can use this to justify our two algorithms used in this project, which are the k-nearest neighbors algorithm and the logistic regression algorithm. In our results, you'll actually see that on this graph right here, there are not only 2 models, but there are 4. We improved on the base models and hypertuned them using the grid search CV module in the Python library to hopefully find a superior version of those base algorithms. And to our surprise, we found that on the receiver operating characteristic curve, the base KNN algorithm performs overall better than the 2 hypertuned models and the base logistic regression model. And in the classification report, the various metrics that are important here is the accuracy output, and in the accuracy column we find that the logistic regression model performs overall better than KNN, and depending on what you want to find out from this dataset, to find out what variables are more important than the others, will determine which metric you deem more important in your hypothesis.
Our second dataset is over wine, an increasingly popular good enjoyed worldwide where certain attributes must be in proper proportion to each other to create a quality product. Using machine learning algorithms to aid in the creation of quality wine can be beneficial for many reasons. Some of those including improved product development, increased efficiency, allowing personalized recommendations, and improved quality control. Next, we will look at more details about the dataset and methods used to analyze it.
The second dataset involves specific attributes of the Portuguese Vinho Verde wine. This dataset observes qualities of the wine, such as acidic content, residual sugar content, pH level, alcohol content, and finally, and most importantly, the wine's quality scored on a scale of 0 to 10. Each of these metrics define the level of quality of the wine in some capacity. For example, acidity gives wine its balance and structure, while the pH level affects a wine's color and taste. This dataset gives each of these characteristics a given numerical value with 12 different variables and about 1,600 different observations. The method used to analyze this data includes multiple linear regression, which allows us to model relationships between the dependent variable, which is the wine's final total quality score, and the multiple independent variables, which is the wine's different qualities. Multiple linear regression tracks the linear relationship between the dependent and independent variables and identifies the most accurate coefficients to predict the end variable. By analyzing the relationship between the different qualities of red wine and their impact on the quality of taste, we can gain insights into the most important factors that contribute to a high-quality wine. The second method used is the random forest regressor, which is an algorithm that uses multiple decision trees to create a prediction by averaging the predicted outcomes. It provides a flexible machine learning algorithm that can handle high-dimensional data and complex relationships between input features and output variables. This is especially effective when handling large inputs of variables and complex relationships between data. In this case, we are testing more than 10 red wine characteristics to determine the specific factors that make up the ideal wine. By combining the results of numerous decision trees, this algorithm can account for various factors and identify the most important predictors for the quality of red wine.
Now we can look at the red wine data set. Starting on the red wine data observation slide, you can see we used a snippet of our data head, which we had used for our linear regression models. In the red wine quality data set, we have 1,599 samples, which all contain 11 attributes each. Those attributes include fixed and volatile acidity, chlorides, and the overall alcohol content of each sample. As you can see on the right-hand side, we have the response variable, quality, rated on a 1 through 10 scale throughout the dataset. Moving to the next slide, we elected to use a scatter plot matrix that will help us denote the association that each attribute has on one another. As you can see, some carry significant correlation, while others don't contain any correlation with each other at all. The scatter plot matrix is also useful to us by aiding in the identification of the outliers, as well as determining the distribution of each attribute, as we can see on the diagonal. Most of the attributes tend to be right-skewed, while a few, namely chlorides, density, and pH, are normally distributed. As we move to the third slide, under wine data observation, we have 4 outputs. The first 2 are the base model outputs of the multiple linear regression and random forest regression models, respectively. The third and fourth, as mentioned before, are hypertuned using Grid Search CV, as mentioned by Dylan in the previous dataset. As we can see, we have consistent outputs for the mean average error, the mean squared error, and the root mean squared error, which tells us that the dataset contains consistent attribute contents per quality score, meaning that quality score 10 contents are consistent throughout the dataset with each other.
From these datasets, we can come to a few conclusions. In terms of the income dataset, the major determining factors for whether someone made above or below $50,000 a year were their marital status and their level of education. With regard to the marital status, there was actually a difference between people who were divorced and people that were never married. This may be due to divorced people having to make alimony payments or other costs related to raising a child while living in a single-income household. Their counterparts that were never married tended to be better off economically, perhaps due to not having those costs related to dependence and childcare, while also living in a single-income household. This data can help in the fields such as economics and sociology in terms of diagnosing an economy's health or perhaps developing programs to help people that are making less than a certain amount of money per year. In terms of the wine data set, there were actually a few correlating factors that we found that were related to each other. The fixed acidity had a positive correlation with the density of the wine and a negative correlation with the pH level of the wine. The pH level correlation makes sense as the pH level for acid tends to be towards 0. The free sulfur dioxide in the wine also corresponded with the total sulfur dioxide in the wine, which makes sense as they basically line up 1-to-1. Further refinement of this machine learning algorithm can help wine producers find the right mix of ingredients to make the highest quality wine with what they have.
A more general conclusion outside of our project is that AI and machine learning algorithms can be used in basically any context to determine what you tell it to do. In this class, we use Python, obviously, to fine-tune our project to what we wanted to find, which was the weights and characteristics that ended up impacting our output the most. But you can change your algorithm based on what you're trying to find.